Okay, so in this video I'm going to have a look at area and volume. So we're just going to have a look at some basic shapes, and I'm going to have a look at the area and the perimeter of some of them. So we're going to talk about area, and the area of any shape is just simply the amount of space, that a two-dimensional or flat shape occupies. So it's just the amount of space that a two-dimensional or flat shape occupies. The perimeter then, is just the sum of the lengths. It's the sum of the lengths of the sides. So in other words, you find the lengths of each of the sides and just add them up. That's simply it. Okay, so the first thing we're going to have a look at anyway is just the shape that is a rectangle. So I'm just going to draw these freehand here. Oops, let's start that again. So we got, let's see, these are right angles here. So we're just going to have a look at this shape here. So we have a right angle here, we have a right angle here, we have four right angles actually. So this is the length along here and the width here. Let's say our length is 5 centimeters and our width is 2 centimeters. So we have an area. The area of this shape is just simply the length times the width. So the length is 5, the width is 2, so our area here is 10 centimeters squared. Our perimeter. The perimeter here is just the distance that you go from here, across here, down, across, and back up again. So if you were to walk from here all the way around the edge of this shape, how far would you walk? So you would have to walk 5 centimeters, 2 centimeters, 5 centimeters, 2 centimeters. So in other words, you'd have to walk 2 lengths and you'd have to walk 2 widths. So in this particular case, it would be 2 times 5 plus 2 times 2. So that's just 10 plus 4, which is 14 centimeters. You would walk 14 centimeters all around the edge of this shape. A related shape then would just be a square. So in this particular case, we have a length. We have right angles in here as well. We have a length along here, but because it's a square, the sides are all equal length. So they're all L's, if you like. So if this is 5 centimeters along here, for example, this would be 5 centimeters here as well. So here our area is just going to be length times width, which is just length times length, which is length squared. So in other words, it's just 5 squared, which is 25 centimeters squared. The perimeter is just going to be length, 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 length. In other words, 4 lengths, because they're all the same. So it's just going to be 4 times 5, which is 20 centimeters. And that's really it for a square and a rectangle. Let's have a look at a triangle then. So let's say we have this triangle here. And this triangle here has what's called a base. So that's the edge that's on the bottom here. That's touching the ground, if you like to think of the triangle standing on the ground. And you'll have the height of it here. So this would be the height. And our area, the area of a triangle, is just half the base times the height. Half times the base times the height. It's really just a it's half of the corresponding rectangle. If you imagine a rectangle around here, say going up here, across here, and down here, it would be just length times width, or the base times the height. That would be the area of the entire rectangle. But we're just looking at this triangle here in the middle, so it would just be half of that. So it's half the base times the height. So in our particular triangle here, again, let's say this is 10 centimeters and our height is 5 centimeters. Our area here would just simply be half times 10 times 5. So 5 tens, 50, half of 50, 25, centimeters squared. That would be the area of our triangle. Okay, and the perimeter, you would need to know that edge and this edge here. We already know this is 10, but if this was 2 and this was 3, you would add up 10 plus 2 plus 3 to give you 15 centimeters. Okay, so that's our triangle. Oh yeah, I should do another triangle here actually. Now that I think of it, this is what's called an acute triangle, because each angle inside this triangle is an acute angle, less than 90 degrees. But you could have a triangle that looks, say, something like this, in which case you've got two acute angles, but you've got this angle here which is obtuse. It's greater than 90 degrees. So again, if we have our base here, what's our height now? We can't go from here to here. From here to here is not going to be a height. The height is really from here to the ground, if you like. So we need to extend this out along here like this. Extend the base out, and this is going to be our height here. This is the height of our triangle. So again, you would just, again, if the base is 10 centimeters and our height is, again, 5 centimeters from here to here, what you would just need to do is exactly the same as what you did up here. The area is equal to half times the base times the height, and you would get half 10 times 5, which is 25 centimeters squared. Okay, so that's our acute and obtuse triangle. So let's move on to the next shape, which is a parallelogram. So parallelograms will look something like this. So we would have this side here parallel to this side here. We would have this side here parallel to this side here. So again, we have a base here. And this is really just, it's like a rectangle, if you like, it's just pushed to one side. So we have a base here, and we also have a height, the height of our parallelogram here. So the area of our parallelogram is just simply the base. Well, we'll call it small b. Sides are usually small letters, so the side here would be b, if you like. So it would be b times h. So that's the area of a parallelogram. So again, if this was 10 centimeters and our height was 5 centimeters, our area here would be 10 times 5, which is 50 centimeters squared. The perimeter would just be the 10 plus whatever this is here, plus 10 plus this side here. You would just walk around the edges here, add up all the sides. That's your parallelogram. We're going to look at a trapezium now. So a trapezium looks like something like this. So we would have, oops, let's just do that again. So this would be a trapezium. So you have this side here parallel to this side here. These two other sides are not parallel. So again, here we have a base. Let's call our base this time A. So the A would be the distance from here to here. B is our distance from here to here. And we also have our height. So we have a height here as well. Now the area of our trapezium is just, you add up the two parallel sides. So the two parallel sides would be A plus B. You want to divide that by 2 and then multiply by whatever the height is. So in our case, let's say we put in some numbers here. Let's say our A here is 10 centimeters. Our B here is, let's say, a little bit smaller, 8 centimeters. And our height here is, let's say, 3 centimeters. So just stick those numbers into our formula here. We've got 10 plus 8 divided by 2. And then we want to multiply all that by 3. So that would just be 18 divided by 2, which is 9. We want to multiply that by 3. So 3 9s, 27 centimeters squared. So that would be the area of this trapezium here. The perimeter, again, you just walk around the edges. So it's going to be 10 centimeters plus whatever this is, plus 8 centimeters plus whatever this is here. And that would be so many centimeters because it's a length. Okay, so let's move on to our last shape. Well, not quite our last shape, where we're going to look at a circle. And we're going to look at a sector of a circle as well. Now our circle here will have radius r, and it will have a length. The length would be the distance, or the perimeter of this is just the length all the way around here. So I just want to talk about pi first of all. Now if you imagine you cut this circle, let's say here, and flatten it out, it will look, let's say, like that, and this is L all the way around here. This would be the length L. Our radius here, if we extend it out here, gives us our diameter. So let's say our diameter is this length here. This is D for diameter, which is double the radius. If you take the length of the circle divided by, if you take the length and divide it by the diameter, you will get pi, which is, you know, roughly 3.1415926 and so on. So you'll always get pi if you take the diameter and divide it into the length, the circumference. So let's look at our formula anyway. We have the area of a circle is given by pi, which is multiplied by r squared, pi r squared. So let's see, if our radius here is, let's say, again, we'll go with 5 centimeters. Our length, our area here is just going to be pi multiplied by 5 squared. So it's going to be 25 pi centimeters squared. Now, if we take pi as being 3.14, it's not exactly 3.14. Pi kind of goes on forever. It's an irrational number. So you can take pi as being 3.14. Some people use 22/7. There are various numbers you can use, but let's take pi as 3.14. That would be 25 multiplied by 3.14. So that's, let me just do that quickly, 25 times 3.14. That gives you 78.5. So it would be 78.5 centimeters squared. That's the area of this circle. Now the perimeter of circle is going to be given, if you imagine here you've got a radius here, r, that's going to be half the diameter. What did we say? We said the diameter divides into the length by pi. So twice the radius times pi will give you the perimeter. If you double the radius, you get the diameter, and the diameter divides into the length pi times, so 2r times pi. Usually we write it as 2 pi r will give you the perimeter. So in our particular case here, we would have twice, let's say we'll use 3.14 again, and our radius is 5. So it would be 2 times 3.14 times 5, and that gives you 31.4 centimeters. So in other words, if you were to start walking from here all the way around the edge of the circle, you would walk 31.4 centimeters. Now let's take part of our circle here. So we're going to take what's called a sector. The sector of our circle. So if we take a circle, and we're just going to take part of that circle. So let's take this area here is called a sector. And this angle here, I'm just going to call it theta. This symbol here is the symbol for an angle that I'm going to use a Greek letter called theta. This length here, the length from here to here on the circle, we'll call it L. So we're going to look at the area of our sector, the area first of all of a sector. So we have the area of the entire circle. We know that that's pi r squared. So the area of the entire circle is pi r squared. It'll give us all the area here, but we only want this section of it here. Now this section here is going to be a fraction of the entire circle. What fraction is it? Well, it's going to be theta over 360. Whatever angle this is, if it was 30 degrees, it would be 30 over 360. So we've got to take pi r squared, the area of the entire circle, and multiply it by some fraction. 30 degrees over 360 or 40 degrees over 360, depending on what this angle here is. Okay, that's the area of a sector. Now, the length then, or the perimeter, well, we'll call it the length. This length here from here down to here is our L, okay? So that L there is going to be given by 2 pi r, which is the length from here all the way around to here. The entire length of the circle is given by this here. But again, we just want to multiply it by the fraction of the circle we're talking about. And the fraction of the circle we're talking about is theta over 360 degrees again. So if our angle here was 30 degrees, we take 2 pi r multiplied by 30 over 360. Okay, and that's it. Well, really, I just want to do these two again. This is these are in degrees here. These are degrees and degrees. But let's say we're dealing in radians. So if we were dealing in radians, what formula do you use? Well, we would use the area of our sector. The area of our sector is just given by r times theta. So whatever the radius is here, multiplied by the angle in radians. The angle has to be in radians. And the perimeter, or we'll call it, rather than perimeter, I'll use the word length. Let's do that properly. So it's going to be the length. The length of the sector is going to be given by half r squared theta. So it's going to be half the radius squared times the angle in radians. So these are in, theta is going to be in radians. Okay, and that's it for this, this particular video.